How's it going, AP Calculus students? Mr. Ford here with another homework tutorial. This one is 5.2.2. Let me flip through here and just spot check which ones I want to do. I do not care about 569. I'm telling you that right now. I'm going to throw that one out. That's going to help us quite a bit. I do like 570. Wow. I like 571. I see where they're going with it, though. I don't think 571 is worth us doing, to be honest. 572, yes. 573, yes. 574, yes. 575, yes. That's it. Okay, cool. Pretty straightforward assignment if we get rid of the ones that are just bulky algebra-based problems that are all rooted in optimization, which we're not going to do anyway. 568. At this point, you've got chain rule under your belt, and if you don't, you should go back and check out this math rules box right here. We're going to be practicing the chain rule quite a bit, but if you have some sort of composite function like f of g of x, when you take the derivative of this, what you have to do is you take the derivative of the outside part with the original function inside, and then multiply it by the derivative of the inside part. That seems to be pretty straightforward. It takes a bit of practice to get the hang of it, for sure. So let's try it a little bit. 568, describe how to obtain the derivative of f of x equals g of ax plus b. Now, ax plus b in this case is the inside function. So what I would do here for question A, if you're taking the derivative of this thing, f prime of x, well, you got to do g prime of the original inside part, ax plus b. But then you got to multiply by the derivative of ax plus b, which is just going to be a, like that, just a constant number in front, because the constant b, the derivative of that is 0, and the derivative of ax is just a. So that's the derivative, the dx of ax plus b. That's what's going on there. Now we're supposed to test this hypothesis in part, it's not part B, it's just one question. Check your description by applying it to that function right there. Oh, we got two separate cases here. So let's try f of x equals 5x plus 2. Sorry, square root of 5x plus 2. So when it comes to the derivative, the first thing you got to think about is, well, square root. Square root is one of those ones you should just memorize. If you have the square root of some function u, the derivative of that is 1 over 2 times the square root of u, like that. I just use u as a filler for whatever else is going on inside of that. That's a common enough derivative that you should just kind of memorize it. It's u to the 1/2 power, and that's where it comes from. So if I'm taking the derivative, I need 1 over 2 times the square root of the original inside part, 5x plus 2. But now with chain rule, I also need the derivative of the inside part, so times 5. And so the answer here would be 5 over 2 roots of 5x plus 2, and that's the derivative of that function there. Let's try the other one, which was a cosine, I think. Cosine of 3x? Yes. Yeah, again, kind of the same thing, cosine of 3x. If you think about the chain rule, f prime of x, well, the outside is is cosine. The derivative of cosine is negative sine. The original inside stays, but now you need to multiply by the derivative of the inside, which is just 3. Which makes sense. It's that constant number we're talking about here. So it's negative 3 sine of 3x. And that is that. Chain rule. Chain rule. Very, very easy, very simple to follow. Okay, let's not worry about optimization since we're not going to worry about it. 570, I'm a Geek is announcing her mystery function contest again. Today's mystery function has these properties. Double prime of negative 3 is the same as f prime of negative 3, which is the same as f of negative 3, which is 0. Wow. What do I know about the graph and what don't I know? Okay, let's think about this. I know that the point negative 3, 0 is on the graph. 1, 2, 3, 0. So I know this point is there. And I know that because f of negative 3 is 0. So that's the starting point. F of negative 3 equals 0. Translation, the point negative 3, 0 is on the graph. I know that f prime of negative 3 is also 0, which means I know that it's a horizontal tangent at that moment in time. It does not mean it's a maximum or a minimum. It just means that there is a leveling off of something going on there. I know that f double prime of negative 3 is also 0. And what that means is that there's no concavity there. It's neither concave up nor concave down. There's no concavity at that point. So I know that it can't just be a parabola because that would be concave up, and it can't just be a downward parabola because that would be concave down. My best instinct is something like this. The graph looks something like this at that point. It's both a point of inflection and a critical value. Usually what that means is you're looking at what I would like to call a leveling off point. It's not a maximum or a minimum. It is a critical value because the derivative is 0 there, but any first or derivative test would show you that you can't actually show it's a maximum or a minimum. That kind of happens. That's my best guess as to what is potentially happening there. I don't think I have much to go on other than that. So, okay, let's try. Yes, 371 is, I get what they're going for. They really want us to play around with, well, first of all, you need to know the distance formula for this problem, which I haven't thought about since I taught geometry all those times ago, but it is really just, it's an adaptation of the Pythagorean theorem. A and C are just number examples that you can find an answer for. And then A, B, and D are really showing off your ability to write functions, but I don't really care about that for this class. I'm not worried about it too much. Okay, let's do 572. We are not allowed to use a calculator for these, so let's go crazy. Some of them are going to take a lot of time, some of them will not, but I suspect this next question will take a large chunk of this video, so let's get to work. Let's start with question A, which I'm going to write down off in the space over here, the integral from -1. Oh, I withdraw. A is going to be very, very easy. It's 0. Does not matter what you get for what the inside part is. You're taking the integral from -1 to 1, -1 to -1, and that's just going to make the whole thing 0. So not much to worry about there. Question B is also going to be relatively easy. We just need to think carefully about how we do this. So what's going on here? We're going to take the integral of the derivative of 9x minus 1. So really we're asking, what's the antiderivative of the derivative of 9x minus 1? And the answer is that it's 9x minus 1. That's it. However, since this is a definite integral, we are going to evaluate it from 2 to 0. Because they also have instructions on how they want us to evaluate it. You'll notice I did not put a plus c down because it's not an indefinite integral. I'm going to jump over here to do this. So we're looking for 9 times 2 minus 1 minus 9 times 0 minus 1. So it's going to be 17 minus -1, which is 18, and that's the answer to that question. Pretty straightforward. I have never seen, I like these questions. I like they show up on our review preview. I've never seen a question like that on the AP test. The opposite, though, I have seen every year. The derivative of an integral undoes itself. Question C, here we go. Now we're actually going to get our hands dirty. We're going to do an actual integral. Actually, no, we don't really need to worry about it. It's an indefinite integral. So all we really got to think about is the formula. We're going to find the antiderivative here. So we need this to be t squared. So I need -32 to become -16. Oh, this is a gravity problem. They're testing to see if you recognize this pattern here. -16 t squared plus 12t, and then you put a plus c at the end of it. Gotta have that on there. Not too bad. Question D is also an indefinite integral, so that's kind of cool. Man. The difference here, wow, we got to think carefully about this, guys. This is asking us to think about chain rule. How do you deal with chain rule when you've got an integral situation? So let's start with the inside part, or let's start with the outside part. Whatever we take the derivative of, we need it to be cosine when we're done taking the derivative. So we know it's going to be a sine of something. And the inside part is going to be 5x, because the derivative of sine of 5x would be the cosine of 5x times the derivative of 5. Now the derivative of 5x, which would be 5. So let's just start thinking about this maybe over here. Let me draw a little box here. If we had y equals sine of 5x, if I were to take the derivative, y prime, I would have the cosine of 5x times 5. Now we need that 5 to go away. So our antiderivative has to have a 1/5 out in front in order to cancel out that 5. And then, of course, you got to put plus c on it. There you go. That's a cool problem. Usually, we would teach you a thing called U substitution first before we do a problem like that. But this is one that's a good example of something you could reasonably think about yourself right now before you get a formula for. So that's a cool problem. I like that we're introducing those ideas before we sit down and show you explicitly a formula for dealing this. And then on question E, oh boy. Well, I don't want to evaluate these two integrals separately, and I think we can save ourselves some time if you recognize a couple things. First of all, if you look at the bounds, you got 1 to -1, and then you got 1 to 2. I want to do a couple things right away to, first of all, the integral on the left is backwards. So let's make that negative. Let's do the negative integral from -1 to 1. And that way I can get it to match up with the integral over here and make it just one integral that runs from -1 to 2. I like that quite a bit. Also, and before I can do that, I need the integrands, I need the inside parts to match up, and right now they do not. They are very close to each other, but they don't quite match up now. So what I want to do here is I want to actually factor out a -2 from the first integral, and that will make the integrands the same, 2x squared plus minus 3x dx. I think I got that right. Let's see, would the negative matter? No, the negative doesn't matter because the negative comes from the integrals switching order, but it does not come from the 4x squared and the 6x. So it still would be minus 3x there. Okay, I got it. 1 to 2 of 2x squared minus 3x. The whole objective here is to make this into one integral that I can then think about pretty carefully without doing a ton of work. So, let's see. Can I just bring that? Yeah, let's just ignore that -2 until the end. Let's do -2 times the one integral from -1 to 2 of 2x squared minus 3x dx. And this is the one that we're going to bring off to the side because we got a lot of work to do to solve this one. So I'm going to bring that one all the way over here on my work. -2 times the integral from -1 to 2 of 2x squared minus 3x dx. Okay, let's go to work. We're going to ignore that -2 until the very end. Inside of here, we're going to take the antiderivative. We need x to the third power to be there. And we need to cancel out with a 3 underneath and have a 2 up there. That way the derivative will be 2x squared. We're also going to need a x to the second power. But we need that 3 there, so I'm going to put this over 2 and leave the 3 up there. That will do. That is the antiderivative of 2x squared minus 3x, I believe. And we're going to evaluate this from 2 to -1 and then multiply the whole thing by -2. I think that's what we want to do. So, -2 times our first chunk of this problem. I'm going to make a square bracket inside here. We're going to have 2 times 2 to the third power over 3 minus 3 times 2 squared over 2 minus 2 times -1 to the third power over 3 minus 3 times -1 squared over 2. Careful, just go nice and slow, take your time with this. It's going to be a lot of steps, so let's see. That's 16 over 3, that's 2 to the fourth power over 3, minus 3 times 4 is 12 over 2. We'll deal with simplifying those fractions in a moment here. This will be -2/3, and that will be minus, that -1 squared is still just 3, so that's minus 3 over 2. Like that. Okay, now let's simplify our fractions, or at least get the denominators the same. If I multiply that by 2, that's 32 over 6 minus 36 over 6. I think I got that right. Times 3, yeah. Yes. Oh, they're both equal to 6. What am I thinking here? That's 6 also. Minus, in this parentheses, we're going to have -2 over 3 is equal to -4 over 6. And let's see, 3 over 2 is the same thing as 9 over 6. Okay, let's keep going. 32 minus 36 is -4, 6 in that first chunk. And over here, that's -4 minus 9, that's -13, 6 over there. Okay, so this is -2 times, if we combine them all together, that's -4 minus -13, which is 9/6. And that is the same thing as negative 2 times 3 over 2. And it's negative 6 over 2, which is negative 3. I think I feel pretty good about that answer. I'm looking around at little math things along the way. I think I feel good about that answer, though. Yeah. Okay. Pretty cool. Yeah. All right. Okay. Let's move on with our lives. Next question that I want to look at. 573, calculate the area of a region bounded by the square root of x plus 1 and x squared minus 2x minus 3. We're going to do the calculator for most of this problem. We're a refresher from the previous problem. We're going to do this mostly on the calculator. Let's start by going into our y equals menu, and we're going to graph the square root of x plus 1 and x squared minus 2x minus 3. We're going to let the calculator handle most of the muscle for this problem. Let's go ahead and graph those on a nice little standard axis. Hopefully we'll see them cross at a reasonable place. There we go. Looks like negative 1 to, well, I don't know where that intersection point is there. It looks like the standard integral, I can scroll just a little bit and get that on the same screen. It looks like that's negative 1. I'm pretty confident about that one. Negative 1 does make both functions equal to 0. It does. But the right bound I'm less confident about. So let's use the intersection feature to figure out what that is. Enter, enter, and move over here. Our second intersection is going to be 3.473. That's less fun. Like that. On that entire range, the square root of x plus 1 is on top, and x squared minus 2x minus 3 is on bottom. So when we write our integral, that's exactly how we're going to set it. A big, fat square bracket. Square root of x plus 1 is the first chunk, minus x squared minus 2x minus 3 is the next chunk, dx. That's the integral that we're going to have the calculator evaluate for us. So let's go for it. So the integral from negative 1 to 3.473 of, in parentheses, wow, open parentheses, square root of x minus 1, close parentheses, minus, open parentheses, x squared minus 2x minus 3, close parentheses, dx. Uh-oh. What did I do wrong here? X minus 1. Oh, it's plus 1. That's why. There we go. Think, 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 think. 16.491, which is a great solution for this problem. Hey, that works for me. If it works for you, it works for me. Let's go to the next problem here. 574. Chris found the derivative of 2x plus 5 squared as shown below. Looks like he took 2x plus 5 squared. Looks like he expanded it and got 4x squared plus 20x plus 25, which is correct. Took the derivative of that and got 8x plus 20. I think that's correct. To check his answer, he tried the power rule, and he took the 2 down and multiplied it in front and got 2 times 2x plus 5 and only got 4x plus 10. Of course, his solutions don't match. What's the correct derivative in y? Well, the top one is the correct derivative. This is wrong. And if you're noticing, both the answers, they're just off by a little bit. If you were to take the bottom answer and multiply it by 2, you would get the top answer. And the reason why is because our friend Chris forgot about the chain rule. When you take the derivative, dx, of 2x plus 5 squared, you have an inside function, 2x plus 5. Now this is going to give you 2 times 2x plus 5. We are using the power rule on the inside chunk, but then you have to multiply by the derivative of the inside chunk, which is just 2. That's what he forgot to do. Forgot to multiply by the derivative of the inside part, and that's why he's missing that chunk. 575, we're going to use all the derivative tools to determine just the derivatives for these. Here we go. Let's make it happen. For question A, h prime of x, the derivative of cosine is negative sine. You leave that inside part alone. Now we're going to multiply by the derivative of it. The derivative of x squared is 2x. So our final answer is negative 2x sine of x squared. That's the derivative for A. You're going to see these patterns over and over again for these problems. Let's try B next. I'm going to do B over here. h prime of x. Let's start with a third power. This is equal to the sine of x to the 1/3 power. Let's start with a power rule chunk. That's going to be 1/3 times our inner portion, which we are not going to touch, raised to the negative 2/3 power. We can clean that up later on, my friends. We'll deal with that in a moment. Or we can just not deal with it at all, honestly. And then we got to multiply by the derivative of our inside chunk, which is the cosine of x. And honestly, this is the kind of problem you could just walk away from. I'm going to make it look nice because I like it. 1/3 times. That is the cube root of sine squared of x. And then a cosine x should be on top of that. You can start to see that your derivatives are starting to look a little more and more funky. That's okay, they happen. Question C. This is just a straightforward power rule problem. Nothing really complicated to do here. We do have to deal with 6 times 2/3 x to the negative 1/3 power. A little bit of stuff there. 6 times 2 is 12. 12 divided by 3 is 4. So it's 4. Actually, it'll be 4 on top and the cube root of x on bottom. For question D, here we have a product rule problem. If you recognize what's going on, you have a thing multiplied by another thing. So this is going to require the product rule. I do not see chain rule being necessary here. You might think chain rule is necessary for this chunk over here, and it kind of is, except for the derivative of x minus 1 is just 1. So the chain rule is there, you just don't see it because it doesn't do anything. However, we are going to need to do, this is for D, we are probably going to want to set up a little product rule grid, which is usually a good idea. F of x is 1/2 times x to the 5th. G of x is the square root of x minus 1. F prime of x is equal to 5/2 x to the 4th. And g prime of x is going to be 1/2 roots of x minus 1. Again, I'm just running through that simple derivative. It's a good idea for you to just memorize the derivative of the square root of x. So, at this point, we're going to use the product rule. We're not going to simplify a ton of anything. H prime of x. Let's start with the original f times the derivative of g. The 1/2s in front will actually combine together to make 1/4, 1 on top, 4 on bottom. We are going to have x to the 5th on top, and we're going to have the square root of x minus 1 on the bottom. There you go, multiplying those two together. Then we're going to multiply the original g times the derivative of f. So put a plus sign down. I don't really have a good way to do this. So let's leave 5x to the 4th on top, right next to the square root of x minus 1, all over 2. I like that derivative. It's not a very clean one, but that is what it is. That's your derivative. Question E is also going to require the let's see, I got to think about this one. 2 sine 1 over x. This one's going to require, well, it might be helpful to think about this before we get too far into it as 2 sine of x to the negative 1st power. So your inside bit is x to the negative 1st. So let's draw a line here. This is for E right away. H prime of x. Well, the derivative of the outside chunk, 2 sine, is going to be 2 cosine. And we'll leave our 1 over x inside of that because we're going to leave that alone. Now we're going to multiply by the derivative of the inside chunk, 1 over x. The derivative of x to the negative 1st power is negative x to the negative 2nd power. So if we were to clean that up, we don't need to, but if you wanted to clean it up, it would be negative 2 on top, x squared on bottom, times the cosine of 1 over x. There you go. Again, just cleaning up the 2 and the negative x to the negative 2nd power like that. And then finally, we have another product rule problem. Let's go ahead and section off some area to work with this one. Again, you can ignore the negative 4 until the very end, which is what I'm going to do. Or you can leave it as part of your first chunk, doesn't matter. F of x is equal to the cosine of x. G of x is the sine of x. So f prime is equal to the negative sine of x, and g prime is equal to cosine of x. And so for the product rule, we're going to multiply cosine times cosine, which is cosine squared. This is h prime of x. I'm going to leave negative 4 out in front, since it doesn't do anything except multiply later on. Cosine times cosine is the cosine squared of x. And then plus, oh, look at that, negative sine times positive sine, plus negative sine squared of x. And that will be those two multiplied together. And then you just distribute the 4. Negative 4 cosine squared plus 4 sine squared. Because the negatives and pluses cancel out. Woof. I'm all over the place with this work, though. If I zoom out, I did everything. Did all the problems, but they're all over the place there. Whew. Derivative rules, man. Product rule, chain rule. Keep them close to your heart. They will help you all the time. I will see you in the next video. You guys are awesome.